Active Directory replication. Active Directory is a great tool, and nowadays it's hard to imagine supporting Windows networks without it. But something that seems to elude a lot of people is how replication works and how we can actually verify that it's working. Now sure, you could create an object in Active Directory and then check another domain controller to see that it's been replicated, and that's certainly one method to use to ensure that replication is working for that domain controller at least. But if you have 10 domain controllers or 50 or 100, who wants to do that? So in this video we'll look at tools and methods you can use to verify that replication is working, and we'll also talk about what replication is and how it works. Firstly, what is replication? Well, it's just the process of making sure that all of our domain controllers have the same information. For example, we might have created a user account in our domain controller in our head office in New York for a user in our London office. So Active Directory will need to replicate that user account over to the London domain controller, so the London domain controller can authenticate this new user when they first log on to the domain. Without replication, the London domain controller would have no knowledge of this new user account and would deny the user from logging onto the domain. Similarly, if we'd only changed one of the properties of a user account, say we've changed the address on an existing user account, then we'd only want the change of address to be replicated across to our other domain controllers and not the whole user account. That way, the replication is quicker and uses less bandwidth. Now, one of the services that make this all possible is the Knowledge Consistency Checker, or the KCC as it's better known. The KCC's job is to build connection objects between two or more domain controllers, and then every 15 minutes it'll check to see if anything's changed in your environment, and then automatically update the replication topology if it finds that domain controllers or sites have been added or removed from the network. So here we have 4 domain controllers all in the same site, all configured in this ring configuration, where each domain controller can replicate with its replication partner in both ways. For example, if domain controller 1 here has an object change on it, it'll notify server 2 and 3 that there's an update, and then these servers will pull the change from server 1. Then once servers 2 and 3 have that updated object, they'll then replicate it to server 4. Now, one of the limitations of the KCC is that it only supports a 3-hop limit, and for our ring configuration here with 4 domain controllers, that's not a problem since it's only 1 hop from server 1 to server 2, and it's also 1 hop to server 3, and 2 hops to server 4. But when we add in a lot more domain controllers, so now we have 8 of them, this poses a problem, because now if we have a change on server 1 and it needs to be replicated, server 5 is now 4 hops away, which of course is greater than the 3-hop limit. So the KCC will then convert this to a mesh configuration by creating more connection objects so that in any situation there'll only ever be a 3-hop limit. So with our mesh topology in place, server 1 can now replicate to server 8, which is 1 hop away. Server 8 can replicate with server 4, which is 1 hop away. And server 4 can then replicate with server 5, which is also 1 hop away, and that means it's again only been 3 hops in total. So let's take a look at how replication would work here in a single site. Let's assume we've just updated a user account on domain controller 1 here. Now if we're running our forest at the Windows 2003 or 2008 functional level, the domain controller will wait 15 seconds after that change has been made. Then after 15 seconds, it's going to notify a replication partner that a change is available. This replication partner will then pull the changes from domain controller 1 using a remote procedure call or an RPC connection. Now after this replication with domain controller 2 is complete, domain controller 1 will wait another 3 seconds, and then it's going to notify domain controller 8 here that there's a change available. And of course, domain controller 8 is then going to pull those changes from domain controller 1 using RPC. And of course, domain controller 8 will then pull those changes from domain controller 1 using an RPC connection. Now, since a change has been made on both domain controllers 2 and 8, they'll both wait 15 seconds, and then they'll notify their replication partners that they have an update, and the same process will ensue. And all over, this means that for every single domain controller in the site to have processed this one change that all started up at domain controller 1, it's going to do it in around 45 seconds or so, which is far quicker than it is if we're running our forest at the Windows 2000 functional level, where it could take around 15 minutes for the same thing. Now, the only time that this process of wait 15 seconds and then update the other domain controller is not followed is when we're dealing with a security-related change, in which case those are sent immediately. So all of this that we looked at is for intra-site replication, where all of the domain controllers are in the same site. For inter-site replication, where we want to replicate a change from this site to another site, that's the responsibility of the Inter-Site Topology Generator service, and we're going to talk more about that in a moment. Now, if you'd like to be able to monitor when the KCC runs, we'll need to make a registry edit for that. So we'll go and click on Start, and we'll type in regedit, and we'll hit Enter. And now we'll go and expand HKey local machine, followed by System, Current Control Set, Services, and we'll scroll down a bit, and we'll expand NTDS, and we'll select Diagnostics. Now in the right hand side here, I'll just move this across, we'll expand Knowledge Consistency Checker, we'll double click on that, and we'll change the value here from anywhere between 0, which is what it's currently set to, and 5. Now, 0 won't write anything to the event log, and 5 is going to write lots of stuff, so I'd set it to around 3 to see how we go. Now, we won't need to reboot this domain controller, this will be in effect straight away, but in order to generate some KCC events immediately, I am going to restart this server, and we'll come back in a moment. Okay, our server's now been restarted, so we'll go and click on Start, and we'll go to Administrative Tools, and we'll launch the Event Viewer. Then on the left here, we'll expand Applications and Services Logs, and we'll select Directory Service. Now over here in the middle, we're looking for a few events here from our Knowledge Consistency Checker, and we can see we've got a couple here. So firstly, a little bit lower, we can see a 1007 event, and that tells us that the KCC is started. Up here we've got a 1009 event, and that tells us that the KCC has started updating the replication topology. And then you can see another one here, 1013, and that'll be the KCC terminating the job. Now you will find more KCC events in the event viewer than these few we've just looked at, such as failures to replicate, and they're going to appear here as well, but we won't see these KCC has started and stopped events unless we make that change in the registry, so it's been worthwhile pointing that out. Now let's move on, and we'll talk about how sites replicate domain controller data to other sites. Although I will point out ahead of time that we're not going to discuss sites in any great detail in this video, since we've already covered sites in an earlier video. So here we have 2 sites with 8 domain controllers in each site, and since we already know how replication occurs within a site using intra-site replication, we don't need to cover that again. This image here should be quite familiar to you. So let's say that again domain controller number 1 has a change that it needs to replicate. It'll go through the exact same process we talked about a moment ago. However, we now have a second site here, so this change will need to be replicated over to that site in some way. Now this replication across sites is handled by one specific server in each site, and it's known as the bridgehead server. These 2 bridgehead servers will replicate with each other and grab a copy of any required changes. And then they'll begin the process of replicating those changes to the domain controllers within their local site using intra-site replication, just the way we've already discussed. Now, unlike intra-site replication, inter-site replication will occur during scheduled periods, and if there have been directory changes and replication is required, then the changes are pulled to the domain controllers that require the changes. Now, inter-site replication doesn't use remote procedure calls like intra-site replication does. It uses either IP or SMTP. So to find out what our replication interval is, or to change our inter-site replication frequency, we'll go and click on Start, then we'll go to Administrative Tools, and we'll launch Active Directory Sites and Services. Now on the left, we'll expand Sites, and we'll expand Intersite Transports. Now we'll select the IP container, and in the right hand side here you can see the default IP site link. So we'll right click on that and we'll choose Properties. Now down the bottom here we can see that for intrasite replication we'll be doing that every 3 hours. Now you can change this value to as frequently as 15 minutes or as long as 10,080 minutes, which is a week, but in most cases you'll probably want to make this value smaller, not larger, especially if you have fast and reliable WAN links. Now let's move on and we'll take a look at what will probably become your favorite tool for troubleshooting replication problems, and that's RepAdmin. But before we get stuck into that, I want to cover a couple of finer points about replication that you might just find not only interesting, but useful when you start using the RepAdmin command. When an object changes in Active Directory, how does the other domain controller know that it doesn't already have the updated object stored in its database? How can it tell if the version of the object it has is newer or older than the one on the other server? Well, Active Directory uses update sequence numbers, or USNs, that are a 64-bit value maintained by each domain controller in Active Directory. Now, when an object is changed in any way, the domain controller where the change is made increments this value by 1. So let's say we have a user account with a USN of 10,000. When we make a change to it, for example, we might modify the telephone number in the properties of the user account, this will increment its USN by 1. So now it has a USN of 10,001, and since this is the most recent change on the domain controller, it now has the highest update sequence number for any attribute stored on that domain controller. So our first domain controller is going to notify the replication partner of the change. So DC2 will ask DC1, what's the highest value USN you have? DC1 will reply with 10,001, and if DC2 has a lower value for DC1, it knows that changes will need to be replicated. If it has the same value, it knows that it already has the latest updates. So if it has a lower value, say 9,950, DC2 knows that it will need to replicate 51 updates from DC1. Now, once these updates have replicated, DC2 now knows that DC1's highest update sequence number is 10,001, and this is known as the high watermark. So on the next replication cycle, DC2 already knows that the high watermark value for DC1 is 10,001, so it asks DC1 what value it has. Now if that's still 10,001, then DC2 will not replicate anything since it already has the most current information. These two servers, though, will maintain their own local update sequence numbers, and later on in this video, when we look at using the RepAdmin command, you'll see that both servers' update sequence numbers for the same objects are different. For example, DC1 might have a local update sequence number of 10,001, but DC2 might have an update sequence number of 8,500 for the same object. But that doesn't matter, as each domain controller will also maintain a record of its replication partner's update sequence number for those objects anyway. Now, also, if a server happens to encounter an error or it dies during the middle of writing a change to an object, then that change will not be replicated, since the last thing a domain controller needs to do before being able to replicate a change is to update the USN. Now, if the USN doesn't get updated, the object isn't replicated, so that can prevent problems with replicating failed changes in the event that the server itself fails. Now, there can also be a problem that can occur with USNs, and that's when an object is modified, but before it's had time to replicate, that same object is modified on a different domain controller. Now, this is referred to as replication collision, and this problem is solved through property version numbers. So let's say on DC1 we change the password on a user's account. Now, before that password has replicated to DC2, we go and change the same user's password on DC2. So which one wins? Which one's the password that's used, and what happens to the loser? Well, the eventual winner of this conflict will be the domain controller that wrote their change last, or in other words, the most recent change. So in this example here, DC2 wrote its change 3 seconds later than DC1, so it's going to win, and its change will be replicated to DC1. So sometimes, I guess it pays to be last. Now we'll see a little later on in this video more about these USN and property version numbers when we start looking at the RepAdmin command, and like with our update sequence numbers, we'll also see the property version numbers incrementing by 1 each time that we make a change to an object's properties. But before we get into that topic anymore, I do want to touch on some of the basic switches first. So let's go and open up a command prompt, and we'll just expand this so we've got a lot of room to work with here. And if we type in RepAdmin and we follow that up with a /? and hit enter. Now if we go and scroll up a little bit, you'll see that we do have a lot of options with this command, so we're not going to go through every single one of them since that'll probably require a couple of videos alone. So we're just going to take a look at a few of the ones that you're going to find most useful. Now, when you're troubleshooting replication problems, obviously one of the first things you'll need to know are which domain controllers that you're replicating with. So if we type in our RepAdmin command and follow that up with a /show REPL and hit enter, this will run that command against the local domain controller that we're currently connected to. But if we want to run it against a different domain controller, we could rerun this command and add in, say, DC03, for example, and this will run the command against DC03. Alright, now let's go and scroll up, and at the top of this output we can see this command has been run against our server DC01, which is a member of the default first site name site. We can see here that it's also a global catalog server, and our site options is none. Now, in this site options field here, you'll see if this site has any additional configuration options set. For example, if the site has universal group membership caching enabled, or if the KCC has been disabled. Actually, let's go and quickly click on Start, and we'll go to Administrative Tools and we'll launch Active Directory Sites and Services. Now we'll select our site here, and in the right hand side of our console we'll right click on NTDS Site Settings and choose Properties. And let's go and enable Universal Group Membership Caching, and I'll click Apply here, and we'll go back to the command prompt. And let's just type in CLS to clear the screen. And we'll rerun our command again. And now if we go and scroll up to the top, we can see that our site options has now changed to identify the fact that Universal Group Membership Caching has now been enabled. Now on the next two lines here, we can also retrieve the GUID, or the globally unique identifier of this directory services as well. And you might want to remember that you can find the GUID here since we will be using it later on. Now, this value here will never change over the lifetime of your domain controller. However, the next value, the invocation ID, which is the database signature, this can change, and it will when application partitions are rehosted on the domain controller. Now you might also note that in my case here, both of these two values are identical since this is my root domain controller and I haven't had any domain partitions rehosted, so the value stays the same. However, if we go and rerun this command again, but we'll add in DC03 to the end of it, and if we scroll up here, you can see that the two GUIDs here for this machine are different. Alright, well let me get my original command back again. Now the other thing I should point out about this object GUID here is that this will also be registered as a CNAME record in DNS. So if we go and click on Start, Administrative Tools, and we'll launch the DNS console, and we'll expand our server, and then our forward lookup zones, and if we select this _MSDCS folder here at the top, in the right hand side, you'll see our GUIDs for each of the three domain controllers that I have here in my forest. Now you might also note that if I double click on any of these, and I'm just going to copy this fully qualified domain name field here, and if we go back to our command prompt, and I'm just going to type in ping, and then we'll right click and we'll paste that information in. Now you'll see that we can ping that domain controller using the GUID. Now this is important because if you're having replication problems due to DNS, one of the first things you should check is that we can resolve the GUID of your domain controller to the correct DNS name. Now also, under the output of this command, if we scroll up, you can see that all of this output falls under the category of inbound neighbors. So why is that important? Well, replication is always inbound. Remember, we don't push changes to domain controllers, we pull changes. So these connections that we're looking at here are for pulling changes into this server when there's been a change on either DCO3 or DTCO1. Now, in the rest of the output here, you can identify each naming context, or partitions if you like, that are being replicated. Now, it really doesn't matter if you call them naming context or partitions. Technically, naming context is the correct term, but you'll hear both terms being used. Now, firstly, at the top here, we have the configuration naming context, which contains information about the forest structure, including trees, domains, trusts, sites and subnets and so forth, and this will be replicated to all domain controllers in the forest. Now, underneath here, we have the schema naming context, and this naming context is also replicated to all domains in the forest, and it defines the rules for creating objects and modifying objects in the forest. A little bit further below, we have an application naming context, forest DNS zones, which holds the resource records that are intended for replication throughout the forest. And the final two partitions here, these are naming contexts for the London and New York domains, and these will hold things like users and groups and computer accounts and so forth. Now, if we also take a closer look at some of the other lines of output here, you can see the site and the server that we've been replicating with and what type of method of replication we used, which was RPC. We can also see the object GUID of the replication partner and some information about the time and date of our attempt to replicate and whether it was successful or not. So, as you've just seen, just from this one switch alone, there's a lot of information that you can gather using RepAdmin, and we haven't even touched the tip of the iceberg yet. Now, by the way, just to sidetrack one moment, if we go and click on Start and type in ADSI, and we'll launch the ADSI Edit program, and of course some people call it ADSI Edit, take your pick, it doesn't really matter to me, and we'll right-click, we'll choose Connect To. Then from the middle of this window in this drop-down box here, we could choose a naming context from this list. So let's choose, say, the configuration one, for example. So we'll click on OK. And if we go and double-click on our configuration and then the next container here, in here, you're going to find some of the things that I mentioned earlier, like sites and services and so forth. So on a lab box, go and have a poke around in here, and it will probably help you understand more about where things are located in Active Directory. Alright, well, let's go and close that down. We don't really need that. It's just a thing I thought I'd point out for you. Now, another RepAdmin switch that we should talk about is Show Connection. So let's go and rerun this here, because I'm too lazy to type it all out. So we'll type in Show Con. Now, when we run this with no other switches, again, it's going to run against the local machine, DCO1 in my case, and it's going to show the connection objects that we have with other domain controllers. So let's go and scroll up to the top. And here we can see that these are KCC generated connection objects. We can see the connection's name, the server name, and the server's distinguished name. And underneath this, amongst all of this output, you can see if we've had any failures using this connection. And for all of the naming contexts, we can see that we are using a ring topology. And we talked about that in an earlier video. If you want to find out a quick overall summary of the health of Active Directory, we can run the RepAdmin followed by REPL summary. And over on the left here, underneath our source column, it's going to show us the replication status of domain controllers performing outbound replication to other domain controllers. And under the destination column, it'll show you the replication status of domain controllers performing inbound replication to other domain controllers. Now, this largest delta column is going to show you the longest replication gap of all replication links on each domain controller. Fails will show us how many replica links are failing to replicate, and that could be useful to identify that you have a problem. Now, the total column here is the total number of replica links on this domain controller, and there'll be one for each naming context, and the percentage column here will tell you how many failures you've had in relation to the number of replica links that you have on the domain controller. Now, if per chance you are having problems with one of your domain controllers, you will see an error here in the error column, which can be an obvious starting point to help push you in the right direction as to where you can look to start solving the problem. Now, in my experience, the first thing you'll likely do is to run the RepAdmin command with the show REPL switch against the domain controller that you're having problems with, and then this command that we've just looked at, and that should tell you if replication is indeed failing. Alright, well, let's talk a little bit more about replication, but first we'll go and click on Start, and we'll go to Administrative Tools, and we'll launch Active Directory Users and Computers, and let's quickly go and create a new user account. So we'll do that inside our Users OU. So we'll right click here, we'll choose to create a new user, and we'll give this guy a name, we'll call him Bob, and we'll make his UPN the same. And now we'll just give Bob a password. We'll type it in again just to confirm it, and we'll leave all the defaults as they are. It's not really important. We'll click Next and then Finish. Alright, well, let's go back to our command prompt, and we're going to rerun our RepAdmin command. So we'll type that in, RepAdmin. This time with the show meta switch, and then we'll specify the full Active Directory path of common name equals Bob, common name equals users, and that's our users OU. Domain component equals Winstructor Lab, domain component equals com, and we're going to run this against our domain controller DC01. So we'll hit enter. Now, what we'll get back here is a list of all of the attributes for Bob's user account. Now notice over here on the left hand side we have all of the update sequence numbers. Now also take note here of this version column, and this is those property version numbers that we spoke about earlier in this video. So with that in mind, let's quickly go back to Active Directory Users and Computers, and we'll go and make a change to Bob's account. So we'll right click on his account, we'll choose Properties, and we can make any sort of change here. And why don't we make a change to his phone number because that's blank. In fact, if we actually go back to our command prompt first, you will notice here in our attributes column there is no entry for his telephone number. So let's go back to Active Directory Users and Computers. In fact, I'll minimize this because my window's behind it, and we'll make a change to his telephone number field. Let's just give him a number of, say, 8. It doesn't really matter what I put in here, and we'll click on Apply. And then we'll go back to our command prompt, and let's run that same command again. Now, this time you might notice a few things have changed. First of all, up here, Bob now has a telephone number attribute, and on the left we can see that attribute has a USN of 16,474. And this telephone number attribute also has a version number of 1. Okay, so let's minimize this and let's go back and change his phone number again to something else. So we'll change it to 85 and we'll click Apply. And we'll go back to our command prompt again. We'll rerun our command again. Okay, well this time we can see that his update sequence number has changed from 16,474 to 475, so that's been incremented by 1. And over on the right here, the version number has also increased by 1. Now, if you recall earlier in this video when we spoke about update sequence numbers and property version numbers being used to identify what objects or attributes need to be replicated, well, if it didn't make any sense back then when I was referring to it, maybe it does now. We can visibly see these numbers change when we make a change to Bob's user account. Now, we could also rerun this same command again and just change DC01 to DC03 and hit enter. Now, since we've given it a few moments, we also should see that this change here with Bob's telephone number has also been replicated. So under the version column, we can see that Bob's telephone property, or attribute rather, has a version number of 2, and that indicates to me that replication is working fine. Now on the left hand side here you can also note that the local update sequence number for this attribute, and this is what DC03 stores this value as, and in the middle here you can see the originating update sequence number, which is what DC01 stores the value as. Now it doesn't matter that quite obviously these two values here are different, as each domain controller will keep a record of its own update sequence numbers as well as the update sequence number of each replication partner as well. So the next time DC03 here needs to replicate data from DC01, it already knows here what the update sequence number is for all of these attributes, and it can check against its own records to ascertain whether it needs to replicate anything. Now, That's all well and good when you know exactly what object you're expecting to be replicated and you can locate it and search for it explicitly like I did here. But what if you have no idea what attributes need replicating? Well, if we want to see what hasn't yet been replicated, we can use the Show Changes switch, and that'll show us what differences exist between domain controllers. But before we run this command, let's go up through our command history again. And I'm going to rerun the RepAdmin show REPL command and hit enter. Since if we scroll up to the top of this command, I need to grab the GUID here. So I'm going to right click and choose mark, and I'm going to highlight our GUID and hit enter, and that's going to copy it to my clipboard. Now let's go and clear the screen, and we'll type in RepAdmin followed by the Show Changes switch. And since we want to see the differences between two domain controllers, let's pick DC01 and DC03. So we'll enter in DC03 first, and now we're going to right click and paste our GUID in there, remembering that's the GUID of DC01. And finally we'll enter in the domain component of Winstructor Lab and the domain component of com. Okay, now from the output here, right off the bat, you can see down the bottom that there aren't any changes that need replicating, but I'll go and fix that in a moment. Also, by this point, most of the fields you see here should be familiar to you, as we've covered almost everything that you're going to see here. We can see the site, we can see the domain controller DC01, which is replicating via RPC. We can see the object GUID, the address, the database invocation ID. This domain controller is scheduled to synchronize on startup and perform scheduled synchronizations as well. We can also see the highest watermark value, and on the final couple of lines we can see both domain controllers' object GUIDs and their highest watermark value as well. So let's go and make another change to Bob's telephone number again. We'll change 85 to 858 and we'll click on apply. Now let's go back to our command prompt and rerun our command again. Now this time at the bottom we do have a couple more lines appear in the output, starting with this line here, objects returned 1. Now this tells us that DC03 has one object that it needs to replicate from DC01, namely the telephone number, which has the value of 858 here. So now that we know that there's changes that need to be replicated, we can force replication by using the Active Directory Sites and Services console, and we saw how to do that in our video on sites. Or we could run the command RepAdmin followed by the replicate switch, and we'll replicate from DC03 to DC01. And finally we'll need to add in the domain component of Winstructor Lab and the domain component of com, and we'll hit enter. And we can see that the synchronization from DC01 to DC03 completed successfully. Now, do bear in mind though that this replicate switch will only replicate one domain controller with another. You can't force replication across all of your domain controllers. In this video, we've talked about replication, specifically how replication works with both intra-site and inter-site replication. We also took a look at how we can use the RepAdmin command to find out things like who our replication partners are, when the last time replication took place, what objects or attributes haven't been replicated, as well as how to kick off replication as well. We hope you enjoyed this video and would like to thank you for supporting Winstructor.